Hello, this is Paul Phim, part of Team 1 in software engineering, ethics, and legal standards. The remaining members of the group are Ishraq Kareem, Ben Ross, and Christy Boyd. We're going to be talking through the pros and cons, the hypotheticals of a world of technology without any kind of standards. The topic for this week is pretty broadly the historical and economical impact of software standards and practices. The two big examples, and these are the two big examples that you could really give in software development, are the Unix operating system and Java, the program language. These are, in a lot of ways, probably the hallmarks of standards and practices when it comes to software developing products. Java boasts something like 9 million developers or 9 million licenses, I think, as of about 3 or 4 years ago. And Unix has persisted almost untouched at its core for a couple of decades now. Even a lot of the substantial changes to the Unix kernel used in Mac OS really haven't done that much to differentiate the underlying architecture from what originally existed. Unix, maybe because it was very developer centric, took off pretty steadily after it was unveiled, and has not really died off all that much, even as server architecture has started to expand more along the lines of Windows operating systems and containerized instances. In looking at thinking through a world without software development practices and standards, we opted to take the approach of looking at the pros and cons of living and working within that world. It's, in a lot of ways, a little easier to look at the possible consequences of such a dramatic change as that, rather than, do all the world building necessary to imagine the hypothetical career path of someone living in that world. Now, with that, development practices are probably the most logical place to start, since that is, in this program, what we spend most of our time really talking about. And so with that, the pros is short but sweet. The truth is, without development practices, standards, without everyone typically working problems the same way, you may actually have a better chance at benefiting from that wild card factor. People having to constantly come at problems again and again and again that, we have been able to not necessarily automate away, but develop away, might help uncover some solutions that developers today just don't really get a chance to go back and bang their head against. Now, on the flip side, of course, you have almost the exact opposite problem. If you're constantly having to bang your head against the same problems over and over again because no one has really come up with the universal way to do it, then you're probably going to be spending more time reinventing the wheel than you are doing the really meat and bones, the really innovative development work at the edges of the field that most of us really enjoy doing. If you're constantly having to reinvent string objects in your code, then you're not really going to be able to do much with string formatting until you've finished that very basic structure. Now, since we do have to spend at least a little bit of time talking about the business side of software development, the price and value of the overall product, whether that be the actual deliverable or the developers, the software engineers' time and effort as the product, needs to be considered. Now, the pros and cons here are, much like in the previous slide, a little bit dicey. Again, it is very hard to anticipate what the world would look like without any kind of standards or practices in place. But that unpredictability does open up some potential benefits. If software development as a process is less predictable, if the results are harder to anticipate, then more likely you'd find yourself in a bit of a prospector role. The proposed budget for a project might vary wildly, but more often than not be overestimated. And in some cases, a development team might take full advantage of that and give exactly their money's worth and nothing more and nothing less. But in other cases, a business may find themselves having completely overbid for a project and saving a little bit of money when everything turns out peachy keen. With that, though, developers might have a lot more bargaining power. If no one can really easily predict what it takes to finish a given project, then it makes it much easier for a developer to argue their price point based on totally arbitrary values. Of course, the con of that is it can be really hard to argue a price based on totally arbitrary values. If there's no consistent pricing model, if there's no consistent history or track record to look at, you kind of open yourself up to the possibility of businesses taking full advantage of developers who don't quite know what they're biting off because they don't know what it takes to thoroughly plan out a project in a way that makes it easy to predict the overall cost. It may also be that the field just struggles and dies if it becomes too monumentally complex to untangle. If the people who have been in the field for years are the only ones who are able to parse through code, understand existing code bases because of how obtuse it is, then it makes it very hard for an industry to really persist. Now, when we talk about security, generally we're speaking about security as it is implemented during the software development process. But of course, security, given what is being secured, really does overlap a lot with the business side of things as well. But here, more than anything, we are going to be talking about the implementation. The truth is, security is one of those areas of software development where it's very difficult to make an argument for ditching standards and practices. Standards practices, really in the form of implemented protocols, are kind of the strongest pillar of any security implementation in an application or service. Things like TSL, Transport Security Layer, even the common practices like mitigating SQL injection. All of these are standards practices that have been built upon discovered vulnerabilities in existing code bases. Now, discovering the vulnerabilities is all well and good, but if no one is really willing or able to adopt the most obvious solution, which by definition then becomes a standard or practice, then you haven't really done anything to mitigate the solution. You've really just pushed it off somewhere else down the chain. Your application may be secure, but if one of your dependencies is not, then you are by definition not secure. Now, the one pro here is that security through obscurity is technically an option for implementing security. If no one has the faintest idea where to begin, evaluating your code or, decompiling your application, then you're probably relatively secure. But, even then, only probably and only relatively. If you don't really know how you could reproduce your code, then you may not really know where the vulnerabilities are. Without the standards and practices in place, building upon the decades of experience with all manner of vulnerabilities and flaws, you would again be rediscovering the wheel in the worst possible way as people pull apart and break into whatever you've put together. Now, before we really fully wrap up, we do want to spend some time talking through what is probably one of the less frequently discussed aspects of software development, but one that is fairly important, product metrics. Metrics don't necessarily just mean the business KPI metrics that you're tracking in terms of usage, ad sales, what have you. It can very often just mean performance metrics, page load times, endpoint response times, that sort of thing. Now, much of that, much like everything else in software, is built upon typical standards and practices. There's endless number of Stack Overflow pages for any given programming language, generally with the exact same answer, which is don't use this timing method, use this one. And they are generally all in agreement about which timing method for which language you should be using. And that's usually whichever one the developers of that language told us to use. Now, in some ways, that's maybe not a standard or practice, since it's really just a suggestion. But if you really want to get nitpicky, probably most standards and practices are really phrased in the way of suggestions. But probably the only pro of ditching standards and practices and just going wild with your software development styles is that statisticians would have a field day with the wildly huge number of different implementations, different practices, and different approaches to the exact same problem. You'd be able to cobble together endlessly long bar graphs comparing page load times for the exact same page in 20,000 different versions, because no one would have built the page the same way. On the flip side, of course, if you really are just trying to come up with one simple measure of a given application's performance, you may find yourself having to come at the approach differently based on which class you're evaluating, or which library within the application, if maybe classes aren't even being used, if half of it's functional and half of it's object-oriented. But even things like page load time may not be relevant given how a given UI is developed for half of a service. What that does mean, though, is if you can't really gain any metrics on, say, performance or reliability, you may never really know what the weak points, the flaws are in a given application, or the pain points for the user of an application. Meaning there might be flaws that are killing your product, but you'd never know because you have no way of tracking them. So ultimately, summing everything up, it's kind of difficult to really make a convincing, bulletproof argument for a world free of software development standards and practices. Probably the security aspect alone justifies the existence of ISO standards, internet protocols, that sort of thing. If you can never really believe that the person on the other end of that phone line is agreeing to your security standards, then you could never really trust that your data is in any way protected or secure. But more than anything, the pace of development within software probably lends itself a lot to the implementation and the use and reliance on development standards and practices. Even things as simple or as not necessarily vague, but as high level as solid principles. Not necessarily standards, not necessarily practices. They're, best use guidelines, best practices, if you will. But in a lot of ways, they do lend themselves to software that is easily modifiable, easily customizable, easily extended. And of course, by extension, easily innovated on top of. If everyone who takes a look at your code base can very quickly understand what you're doing, they can very quickly make changes and adjustments based on their needs. If, however, on the other side, you have to spend just as much time commenting as you do coding because you are doing something that no one else has ever done in a way that no one else would probably readily understand, you're probably not going to be able to work as efficiently as you would like, and you're probably going to not work as nearly as innovatively as you would like. So, in short, There's that old saying that a rising tide lifts all boats, and in many ways, the basic development practices and standards that we've been learning are rising that tide. If everyone who learns to code can code at least decently well, then it makes it a lot easier for some people to learn how to code incredibly well.